The natural world is full of wonders. Some creatures are big and powerful, while others are small and delicate. The silkworm is one such creature. This tiny insect may not seem impressive at first glance, but it has played a huge role in human history. For thousands of years, silkworms have been prized for their ability to produce silk. This luxurious fabric has adorned kings and queens, and it continues to be a symbol of wealth and sophistication today. The silkworm's scientific name is, it belongs to a group of insects called moths. Unlike many moths, which are nocturnal, silk moths are active during the day. They are also flightless, relying entirely on humans for their survival. The silkworm's life cycle is a fascinating journey of transformation from a tiny egg to a beautiful moth. In this essay, we will explore the different stages of the silkworm's life. We will learn about their diet, their behavior, and their remarkable ability to produce silk. We will also delve into the history of silk production and its impact on human civilization. Join me as we uncover the secrets of the silkworm, a tiny creature with a big impact. The life cycle of a silkworm begins with a tiny egg. These eggs are very small, about the size of a pinhead. They are usually yellow or white in color. A female silk moth can lay hundreds of eggs at a time. These eggs are carefully laid on a special paper or cloth provided by silk farmers. The eggs remain dormant for a period of time, usually a few weeks. During this time, the tiny silkworm grows inside the egg. When the time is right, the eggs hatch and the baby silkworms emerge. These newly hatched silkworms are called larvae. They are very small and black in color, covered in tiny hairs. The first meal of a silkworm is its own eggshell. This provides them with the nutrients they need to start growing. After that, they are ready to start their main diet, mulberry leaves. In fact, silkworms are extremely picky eaters. They will only eat leaves from the mulberry tree. This is why silk farming is often associated with mulberry plantations. Once the silkworm starts eating mulberry leaves, it grows rapidly. They eat almost constantly, day and night. As they eat and grow, their skin becomes too tight. To accommodate their increasing size, silkworms go through a process called molting. During molting, the silkworm sheds its old skin and grows a new one. A silkworm molts 4 times during its larval stage. Each molt marks a new instar, or stage of development. With each instar, the silkworm grows larger and its appetite increases. The silkworm's body also changes color, becoming whiter with each molt. By the 5th instar, the silkworm is fully grown and ready to begin the next stage of its life cycle. The silkworm's life as a larva is all about eating and growing. This period lasts for about 4 to 6 weeks. During this time, they consume enormous amounts of mulberry leaves, storing up energy for the transformation that lies ahead. After about a month of constant eating, the silkworm is ready for dramatic change. It stops eating and starts to behave differently. It becomes restless and starts to wander, looking for a suitable place to spin its cocoon. The silkworm is now ready to enter the pupa stage of its life cycle. The silkworm produces silk thread from a special gland located under its mouth. This thread is made of a protein called fibroin. The silkworm releases the fibroin as a liquid, which hardens into a thread when it comes into contact with air. The silkworm uses this thread to create a protective casing around itself, the cocoon. To spin its cocoon, the silkworm first creates a framework of silk threads. Then it starts to spin in a figure-8 pattern, moving its head back and forth. The silkworm produces a single continuous thread of silk, which can be up to 1 kilometer long. The spinning process takes about 2 to 3 days to complete. Section 5. Inside the cocoon. The pupa's big change. Once the cocoon is complete, the silkworm is completely enclosed inside. It is now a pupa, also known as a chrysalis. Inside the cocoon, the pupa undergoes a remarkable transformation called metamorphosis. During this process, the silkworm's body breaks down and rebuilds itself into a completely new form. The pupa stage lasts for about 2 to 3 weeks. During this time, the pupa doesn't eat or move. It is completely dependent on the energy it's stored up as a larva. Inside the cocoon, amazing changes are taking place. The silkworm's organs and tissues are reorganized, and new structures such as wings, legs, and antennae are formed. The pupa stage is a crucial period in the silkworm's life cycle. It is a time of intense development and change, culminating in the emergence of the adult moth. Section 6. A new generation. The silk moth emerges. After about 2 weeks, the transformation inside the cocoon is complete. The pupa is now ready to emerge as an adult silk moth. The moth secretes a special fluid that softens the cocoon, allowing it to break free. The moth then pushes its way out of the cocoon, ready to begin the final stage of its life cycle. The adult silk moth is a beautiful creature with large white wings covered in delicate patterns. Unlike the larva, which was solely focused on eating, the adult moth has only one purpose: to reproduce. The moths mate and the females lay their eggs, ensuring the continuation of the silkworm life cycle. Adult silk moths have a very short lifespan, usually only a few days. They do not eat during this time, as their mouth parts are not fully developed. Their sole purpose is to mate and lay eggs, continuing the cycle of life for these fascinating creatures. Section 7. Silk, a treasure from nature woven into history. For thousands of years, humans have prized silk for its beauty, strength, and luxurious feel. The silk trade, which originated in ancient China, has played a significant role in shaping civilizations and connecting different parts of the world. The story of silk is a testament to human ingenuity and our enduring fascination with the natural world. The process of producing silk, known as sericulture, involves carefully cultivating silkworms and harvesting their cocoons. Silk farmers provide optimal conditions for the silkworms to thrive, ensuring a steady supply of fresh mulberry leaves and a clean environment. The cocoons are then carefully collected and processed to extract the silk fibers. Silk fibers are incredibly strong and durable, yet also incredibly fine and soft. These unique properties make silk an ideal material for a wide range of applications, from luxurious clothing and accessories to delicate surgical sutures. The history of silk is intertwined with the history of fashion, trade, and technological innovation. Section 8D. The silk trade, a global industry with ancient roots. The silk trade has a long and fascinating history dating back over 5,000 years to ancient China. For centuries, the Chinese closely guarded the secrets of silk production, making silk a highly sought-after commodity in other parts of the world. The Silk Road, a network of trade routes that connected the East and West, played a pivotal role in the global exchange of goods, ideas, and cultures. Silk was a major driver of trade along the Silk Road, along with other precious goods such as spices, tea, and porcelain. The silk trade had a profound impact on the economies and societies of the countries along the route, fostering cultural exchange and shaping the course of history. Today, silk production is a global industry with major producers in Asia, Europe, and South America. While synthetic fabrics have emerged as alternatives to silk, the demand for this luxurious material remains high. Silk continues to be associated with quality, elegance, and timeless style. Section 9. The future of silk, beyond fashion and into new frontiers. While silk is traditionally associated with textiles and fashion, its unique properties are now being explored for a wide range of innovative applications. Scientists and engineers are researching the use of silk in medicine, biotechnology, and even electronics. Silk's biocompatibility makes it an ideal material for medical implants and drug delivery systems. Its strength and flexibility make it suitable for creating artificial ligaments and tendons. Researchers are even exploring the use of silk in regenerative medicine, using silk scaffolds to promote tissue growth. As we continue to unlock the secrets of silk, we can expect to see even more innovative applications for this versatile material. The future of silk is bright, with the potential to revolutionize industries and improve lives in countless ways.